Okay. So before marriage, I'm looking like this. Thing. Got it? After marriage, so I think you'll have the photo in Google, right? That is a recent photo only, right? BSD news for girls. Bad news for girls. Okay. Uh, I'm unable to understand, man. Akash. Oh, right. Got it. Got it. Got it, Akash. No, no, cancel, cancel. I'm taking back those words. Uh, right. Uh, right. Right, guys, let's start. Uh, oh, thank you, Akash. So really, right, guys. So router functions. Router functions. Okay. So in diagrams, we are going to use the symbol to represent router, right? So I'll show you, we'll get few images from internet, okay? Routers. So let's see, guys. This is Cisco router images. We'll have different brands. Those all network routers. Okay. So this is a front view of router, right? And it's a back view. Okay. So switches also same, but it having multiple ports in switches, right? So it's a front view and it's a back view. So front view will have few LEDs and those all stuff, and back view will have auxiliary port and console port, right? So auxiliary port to connect the router into the network, console port to configure. So like this, we'll have few ports to access the device through network remotely into our laptop, into our desktop, right? So router functions. Okay. First point, router is an intelligent device. First point, router is an intelligent device. Clear? So router is an intelligent device. Okay. Second point, it will maintain routing table. Okay. It will maintain routing table. So router is an intelligent device. It will maintain the routing table. A main purpose of the router for path determination. It will decide the best path to reach the destination, and it will enable the communication between two different logical networks. This is the main purpose. Right, guys. First point, it's an intelligent device. Second point, it will maintain the routing table. Third point, it will enable the communication between two different logical networks. Third point, path determination, or otherwise you can say it will decide the best path to reach the destination. Got it, guys? Third point, it will enable the communication between two different logical networks. I'll tell you, don't worry, okay? So let's see, guys. First, router is an intelligent device. Okay. Router is an intelligent device. Right. So this is a router. Okay. So this is one network. This is another network, guys. Okay. This is one network and this is another network. So this is one logical network. Guys, this is physical network. This is logical network. So what is the difference between physical network and logical network means? See, if you establish the network into your organization, that is physical network. If you having physical network, there is no use. Maybe if you having multiple laptops or multiple desktop, you're connected with one wire media, there is no use. You are unable to communicate from one mission to another mission. So we should assign the logical addressing, that is called IP addressing. For example, we have into our class around like online 40 peoples and offline. So offline around 10 to 20 peoples will have, right? Clear, guys? So total 50 peoples will have at present. So how we can able to communicate with 50 peoples? If I have the contact number, then only we can able to communicate. That's it, now. Your contact number, your phone number is an IP address here. So coming to one network, each and every device, it should have the one IP address. Then only we can able to communicate from one mission to another mission. So this is one logical network. IP addresses are logical network, right? And this is another logical network, right? So this is 192.168.1.0 logical network. And this is 10.0.0.0 logical network, right? So guys, we are unable to communicate directly from one logical network to another logical network, remember, because this is a different network. 192.168.1.0 network, this is different network. 10.0.0.0 network. So those both the network by default doesn't have the communication. If we need to enable the communication, we should use one device called router. With the help of this router, we are going to enable the communication between two different logical networks. Now we can able to send the data to this network. We can able to get the data from this network with the help of this router. So this router, it will enable the communication. Without router, there is no communication. I hope you got it, guys. Exactly. Router, what it will do, it may be in your home router also, same thing we are going to do, because home router, public network, private network, both will have, it will enable the communication between public and private network, like the same way here. Got it, guys? Yes, no. Home routers are different. Home routers, they will act like as a broadcast devices, like what we say, hubs, right? Okay. So coming to path determination, guys, this is a intelligent device. It will maintain the routing table. Guys, in this diagram, this router, this is Hyderabad router, automatically it will capture the neighbor's router's IP addresses. It will maintain into the routing table. So because of that reason, it's an intelligent device. Automatically it is going to capture, right? Okay. So path determination also, it's a very, very important. Means router, it will decide the best path to reach the destination. For example, assume this, we have one branch in Hyderabad. So this is Hyderabad network. So here we'll have few missions. Those all the missions, it's connecting to the switch. The switch, it's connecting to the router. This is the architecture, right? So we'll have one network in Hyderabad, and same network, like the same network we'll have in Chennai. Two different branches. Assume this NIT having two different branches. One is in Hyderabad, another one is in Chennai, right? Now Hyderabad peoples, they try to sending the data to Chennai network. Got it, guys? Hyderabad peoples, They tried to sending the data from Hyderabad to Chennai. Excuse me, guys. Right. So now mission one, it's sending the data to switch. Switch, it's will carry forwarding the data to the router, right? This router, it will decide the best path to reach the destination. Got it, guys? So according to this diagram, which one is the best path? Below one or above one? Below one or above one, guys? So this is a best path, right? Because shortest route we are going to consider as a best path. Simple, guys. You are trying to traveling from Hyderabad to Chennai. How you are going to travel? You are going to search the route into the Google Maps. In Google Map, we are going to find shortest route because to reduce the time and as well as to reduce the petrol. That's it, huh? So because of that reason, we are going to select the best route. That is a best path to reach the destination. Like the same way, this router, it will decide the best path to send the data to destination. So according to this diagram, this is a best path because only one hop will have, one router will have. So this side, two routers will have. So always least count is a best path. I hope you got it, guys, right? Okay, so how this router it will decide? How this router it will decide? Got it, guys? So simple. With the help of routing protocols. Got it? So it will decide the best path with the help of routing protocols. Routing protocols. Coming to routing protocols, example RIP. That is not that RIP. Okay. So clear? RIP full form, routing information protocol. RIP full form, routing information protocol from CCNA version 2 onwards. Version 3, version 2 doesn't have RIP. Okay. So before old version CCNA concepts will have RIP, right? So RIP full form, routing information protocol. Routing information protocol. EIGRP, enhanced interior gateway routing protocol. What is that? Enhanced interior gateway routing protocol, that is called EIGRP. And OSPF, open shortest path first. Got it, guys? What kind of protocols we are going to use to send the data? Who is going to decide the best path? Router. So router, what kind of protocols it's try to utilizing to decide the best path? Routing protocols. Coming to routing protocols, RIP, okay, routing information protocol, EIGRP, enhanced interior gateway routing protocol, and then OSPF, open shortest path first. Open shortest path first. Those all the protocols details it will cover in CCNA, routing and switching. Got it, guys? For example, assume thus we are using RIP here. Guys, only one protocol we need to configure into one router. Okay. So here we are trying to configuring RIP. RIP, routing information protocol. How it will work in the sense, least hope count, it will decide the best path. So here only one router will have, this side two routers will have. RIP, it will decide this is the best path to send the data. And coming to EIGRP, enhanced interior gateway routing protocol. So if you configure EIGRP here, so this router, it will decide the best path depend on bandwidth. Maybe this side will have 100 Mbps bandwidth. This side, if you having 1000 Mbps bandwidth, so EIGRP, it will decide this is the best path to send the data. Depends on bandwidth. Okay. This side 100 Mbps will have, this side 1000 will have. So this is the best path according to EIGRP. OSPF, it's a successor of RIP. Successor means nowadays RIP people they're not using, OSPF they're using. Got it, guys? Successor of RIP, advanced version of RIP in our layman language, we can say, right? So I hope you got it, guys. So according to this routing protocol, this router, it will decide the best path to send the data to destination. So now we reach the data into destination. So this router, how he's going to share the data between hosts using routed protocols. So it will send the data to this router. This router, it is going to share the data between the host, right? So how it is going to share the data between the host? Using routed protocols. Coming to routed protocols, IP, Internet Protocol, IP addresses, IPX, IBM machines having IPX, Apple TAC, Apple machines having Apple TAC. Nowadays, no one they're using IPX and Apple TAC. Everybody they're using IPs only. I hope you got it, guys, right? So with the help of IPs, it will share the data between those machines. I hope you got it. Exactly router what it will do. Right? Yes, no. Right. So clear about routers. Guys, this is in legacy enrollment. This is in legacy enrollment, right? Okay. So this is all about network devices, guys. So next, we'll start IP addresses. IPv4 will start now because from routers, we are going to use IP addresses, right? Okay. How many of you know about IP addresses, guys? How many of you know about IP addresses? ఎంతమందికి ఐపీ అడ్రస్ల గురించి తెలుసు అని అడిగాను అంతే. ఎన్ని టైప్స్ ఉన్నాయని అడగలేదు. వినండి క్వశ్చన్ వినండి. First listen the question, man. What I said, how many of you know IP addresses, about IP addresses? Got it? Huh? I think many people you are completed AWS and DevOps, right? Without knowing the IP addresses, I don't know how you are completed. Huh? You need to know the IP addresses, then only you can able to complete the AWS and DevOps. Remember, right? Okay. Class of IP added. Okay. So right, guys. If you know, if you don't know, anyway, we are going to discuss now. Please focus on it. Maybe if you're having any confusion also, you are going to get clear now. No need to bother. Clear? Okay. So IP addresses are logical addressing. Already we discussed, right? IP addresses are logical addressing. Got it, guys? So logical addressing means, before we discuss, like our contact number. Our logical address is our mobile number. With the help of our mobile number, for example, if I having your contact number, then only I can able to make the call. I can able to communicate with you. Then if you having my contact number, then only you can able to make the call to me, and then so we can able to communicate, right? So we need to communicate between two different missions in one network. IP address is a mandatory. Without IP addresses, we are unable to communicate from one mission to another mission in network. Excuse me, guys. So without contact number, how the people they're unable to communicate each other like the same way. Got it, guys? So coming to IP addresses, now coming to mobile networks, we'll have Airtel, VI, Geo, and those all stuff will have. So like the same way here, how many types of IP addresses, how many versions IP addresses will have, how many versions will have? Two versions, IPv4 and IPv6. Why two version? One version is enough, right? Huh? So one version is enough, right? So why they introduced us again IPv6? will have already IPv4, IP address version 4, right? So it's a 32-bit addressing. It's a 32-bit addressing, right, guys? Got it? It's a 32-bit addressing. So this is a formula to know the combinations in IP addresses. 2 to the power of 32. How many IP addresses will have? More than 4 billion IP addresses will have. Clear, guys? So what is the use of IP addresses? To communicate from one device to another device in a network, right? Okay. How many mobiles you are holding? How many mobiles you'll have? 2 mobiles you'll have. See, I know 2 mobiles they're having, two mobiles. One is for official purpose, another one is unofficial purpose. Huh? So घर वाली के लिए और एक बाहर वाले के लिए, right? So two mobiles. So people they're using means 2 devices. How those devices it's working? With IP address only. If you need internet, you need to chat with someone through WhatsApp, to Telegram. If you want to can make the reels in Instagram, whatever it may be, without internet, you are unable to do those all stuff. You should have the internet. So how you're getting the internet? How you are trying to communicating the network? With the help of an IP address. Your mobile device automatically it is going to get one IP address from your Wi-Fi router. ISPs they will provide, that is public IP address, man. For internet, internal your router it is going to provide one IP address to communicate each other inside the home. Okay, we'll have 2 types of IP addresses, public and private. Public IP address for internet, private IP address for intranet. This router it will enable the communication between 2 different logical networks, public and private. We'll discuss what is public and what is private later. So let's focus on it. Just I'm trying to explaining you peoples. So IPv4 range, why it got completed? More than 4 billion IP addresses will have this combinations. It's got completed. We doesn't have an IPv4. Those all the combinations. Without IP addresses, can we able to communicate? So n number of the peoples they're using smart devices. Okay, Google, Alexa, Siri, those all, right? Yes, no. So okay, Google. So, okay, so it got activated. I said okay, Google, right? The mobile it got activated, right? Google. Okay, right. So let's see, guys, here. Many people they're maintaining smart homes. Do you know about smart home? Smart lock. Do you know smart locks, guys? Smart home. Voice over. We can able to open the lock. Okay, Google, open the door. Guys, give me 1 minute. It's reacting. My mobile. Okay, Google means. Okay, Siri, open the door. And Alexa, open the door. So like this, we are going to call and then we can able to open the door. If you go to inside the home, okay, Google, open the curtain 50%. Close the curtain 100%. Like this devices also will have. So switch on the AC, switch off the AC, right? We'll have smart ACs nowadays, right? Those all the devices, it will work depend on IP address. Without IP address, you are unable to communicate from one device to another device. I hope you got it, guys, right? So, for example, we'll have CC cams here, right? CC cams. So, how like management they try to monitoring the CC cam visuals with the help of mobile, So the CC cam, smart CC cam, it having one IP address. Using that IP address, we can able to monitor anywhere with the help of internet. So your mobile having one IP address and your CC cam having one IP address. So those both the devices, it can able to communicate using one IP addresses. Without IP addresses, so we are unable to utilize the smart devices. Remember, smart watches also, man. Okay, got it, guys. Smart watches, actually, we are going to connect with Bluetooth. Bluetooth is a different connectivity, right? Smart watches having Wi-Fi, enable smart watches. You can connect Wi-Fi, then you'll get the internet into your device. Then with the help of smartwatch, we can able to track. So the smartwatch should have the internet. So we'll have like this watches, we can able to connect Wi-Fi. Okay, so I have Samsung watch. We can able to connect the device Wi-Fi into directly Samsung watch, and you'll have some features if you want to get attend the calls, whatever if you want to can do. Right, guys? So that is smart devices will have a number of the smart devices will have. So each and every smart devices, how it is going to communicate with IP addresses. So one guy is like one people's like in our classroom itself only people they're maintaining two mobiles. Guys, I have only one mobile. Okay. So got it, guys. So clear, but I have two SIMs. Okay. One mobile. So got it. So both they know, man. So many people they know both the numbers, right? Okay. So clear, guys. So here IP address shortage. So many people are using smart devices because of that reason. Here IPv4 range 4 billion, more than 4 billion IP addresses, it got completed, finished. Got it, guys, right? So without IP address, can we able to utilize the smart devices? It's a bit difficult to us. So because of that reason, so you are not going to get the sleep if you doesn't have the smart mobile along with you. Nowadays, people like that, they became, including me. Okay, right. So clear, guys? So because of that reason, they introduced to us IPv6. IPv6, right? So here IPv4, IP address shortage. So because of that reason, they introduced to us IPv6. IPv6 is a 128-bit addressing. IPv6 is a 128-bit addressing, right? Guys, my doubt is why 128 exactly? Why not 64? Why not more than 128? Like 254 like that? Exactly why they introduced to us 128 bit? How many of you know this? Apart from my students. నోట్లో ఉంది రావట్లేదు బయటికి కదా ఎక్స్ప్రెషన్ అలాగే ఉంది మీది అక్కడ రైట్ బైనరీస్ అన్ని బైనరీసే ఎవ్రీథింగ్ ఇస్ బైనరీ ఫార్మాట్ ఇట్ సెల్ఫ్ ఓన్లీ then why 128? Why not 64? Why not more than 128? Yes, guys. If someone they ask this question, what kind of answer you're going to give? Sai, ఏదో అలా ఇచ్చారు సార్ అంటారా? So, see guys, our smart devices are laptops. It will support till 128 bit. More than 128 bit, it won't support. It doesn't have more than 128 bit devices. If they introduce to us IPv6 as a 64 bit, again, same problem we need to face, IP address shortage problem. Yes, no. So because of that reason, till and support like 128 bit, it will support till our smart devices. They introduced to us IPv6 as a 128 bit because of that reason. I hope you got it, guys, right? So 2 to the power of 32 whole power 4 means compared to IPv4 in IPv6 will have 4 times more IP addresses. If you want, you can like share the 10 IP address for each and every people throughout world, still you'll have the IP addresses. Got it, guys? Right? Okay. I hope you're clear the differences between IPv4 and IPv6, why they introduced us IPv6, right? But India, like countries, not only India, guys, still few countries, they're using IPv4 only. And the AWS and DevOps, everybody, they are teaching on IPv4 only. No one they're bothering about IPv6. Yes, no. Why, guys? Because in India, still we are using IPv4. Sir, as of now, we discuss IPv4 range, it got completed. How we can able to utilize the IPv4 IP addresses? Yes, no. Because of NAT concept, network address translator. Got it, guys? So India, like countries, still they are using IPv4 because Indian government, they didn't provide the full-fledged permission to upgrade, right? And it's not a that much of easy to upgrade from IPv4 to IPv6. Got it, guys? Nowadays, few peoples they're using IPv6 also because we need to communicate with some different countries. Always we should have the IPv6. I hope you got it, guys. How India, like countries, they are using still IPv4 with the help of NAT concept, network address translator, right? With the help of one public IP address, you can communicate, you can connect 60,000 private hosts. Got it? What is the difference between public and private IP address? Public IP address means internet. So ISPs, they're going to provide the IP address that is public IP address. In our home, from Wi-Fi router, we are going to get one IP address that is private, internal. How to know the public and private IP addresses? Okay, leave about Linux. In Windows, you're all cloud engineers, right? You're completed cloud and then as well as DevOps, right? Then how to know the public IP address and how to know the private IP addresses? We access internet, then only we can able to get the public IP address. Listen the question carefully. So even if you're attending the interview, why you are not going to select, because of this reason. So what I'm trying to asking, so listen carefully and then give the answer. Take the time, it's not a problem. Take a time. 2 to 3 seconds you can think, man, it's no issues. It's not that much of hurry. Right? So listen the question carefully. Very good. Subham, IP config for whom? To know which IP address, public or private? Private. Internal. IP config in Windows, internal. How to know the public IP address? Static IP address. We need to purchase one static IP address like this. Telnet. Who said Telnet? Akash? No. Telnet is a protocol to access the remote machine into our machine, remote device into our device. That's it, like SSH. Got it, guys? Okay. Then how to know the public? Without public IP address, you doesn't have the internet. So this public IP address, who's going to provide? ISPs. From where you are getting internet? ISPs. ISPs from where they are getting internet? Huh? Who's providing those all the IP addresses? In Paknodla. Kaadu kada. Huh? Aina. Very good. Super. So from Aina, from where he's getting? ICANN. Got it. I'll tell you. Give me 1 minute. Open web browser. Then in web browser, Google it. What is my IP? Then you will get the public IP address. Got it, guys? With the help of NAT concept, we can able to communicate 60,000 hosts. So still India like countries, they're using IPv4 because of this reason. Clear, guys? Yes, no, right. So now we are going to discuss little bit depthly about IPv4. So IPv4 is a 32-bit addressing. IPv4 is a 32-bit addressing. 32 bits means 32 zeros and ones. That's it now. Bits, binary language, zeros and ones, right? So 32 zeros and ones. Got it, guys? 32 zeros and ones combination. IPv4 is a 32-bit. It's having 32 zeros and one combinations. I hope you got it, guys, right? So formula 2 to the power of 32. How many combinations will have? More than 4 billion combinations will have. It's a very huge combination. It's a very huge combination. Got it, guys? So because of that reason, ICANN, right? So from where we are getting internet, guys? We are getting internet from ISPs, right? ISP. ISPs from where we are getting? ISPs from there they are getting, guys. ICANN. ICANN, the Internet Corporation for Assigned Names and Numbers. From ICANN, INA, IANA, Internet Assigned Numbers Authority, RIR, and INA to RIR, Regional Internet Registry. From RIR to ISB, ISP to small ISPs, small ISPs to into our home. Got it? So we know only we are going to get the internet from ISPs. ISPs also they need to get the internet, right? Who's providing? ICANN. A few peoples they know INA, but INA also it's getting the internet from ICANN. So those peoples they introduced to us IP addresses. I hope you got it, guys. So total how many bits? 32 bits. So total 32 bits, it got divided into 4 octets. Octet. Got it, guys? The total 32-bit, it's a very huge combination. So because of that reason, it got divided into 4 octets. Each octet having 8 bits. I hope you got it, guys. Each octet having 8 bits. Clear? So finish, guys. Finish. Done. Very good. Akhil. Right. So let's see, guys, here. So total 32 bits. Those total 32 bits, it got divided into 4 octet. Each octet having 8 bits. This is 8-bit octet. And this is also 8-bit octet. This is also 8-bit octet. This is also 8-bit octet. Right? Each octet, it got divided into decimal dot notation. Dot notation. Decimal dot notation. Got it, guys? Right? Each octet having how many combinations? 2 to the power of 8. 8 combinations are ikkada. So 2 to the power of 8. 256 combinations will have. If you are writing from 0, 0 to 255. Got it? So total 32 bits. It got divided into 4 octet. Each octet having 8 bits. So each octet, it got divided in with the help of decimal dot notation. So here we'll have decimal dot notation, right? So because of that reason, we have IP address like this format. 192.168.1.1, because those all the octets, it got divided into decimal dot notation. Guys, it's not an exact value. For example, I'm saying you'll have exact value also. If you want, you can calculate. Go to internet, we'll have the binary calculator. You can put this binary value into binary calculator. It will convert into numerical. Clear? How to calculate binaries also I will teach you now. Don't worry. Without internet, without binary calculator. Right? So let's see here. I hope you got it, guys. Each octet having 8 bits. 8 bits means how many combinations? 2 to the power of 8. Actually, 32-bit means 2 to the power of 32. 8-bit means 2 to the power of 8. 256 combinations will have in each octet. 0 to 255. We are trying to writing from 0. So 256 means we need to do -1 because we are writing from 0. If you're writing from 1, then we'll get 256. If you're writing from 0, we should do -1. That's it now. 0 to 255 combinations will have in each octet. This octet having 0 to 255. This octet also having 0 to 255. This octet also having 0 to 255. And this octet also having 0 to 255. I hope you got it, guys. 4 octets, 4 0 to 255 combinations. This 0 to 255 combination also, it's a very huge combination. It's a very huge combination, right? So who's going to connect more than 200 IP addresses, 200 machines into one network? So because of that reason, what it is only 255. We are writing from 0 now because of that reason, Suresh Kumar. We are not writing from 1. We are not considering from 1. So first bit is 0 only, 0 to 255 only, right? Total combination 256, right? Each octet 2 to the power of 8, right? So why they got designed like this means then we need to ask to ICANN. Because of our requirement only they got designed, and then they introduced to us IPv6 and as well as IPv4. Got it? Why it is only 255 means what I need to do? 2 to the power of 20, 2 to the power of 8, 256 only. Because of that reason, 0 to 255. Each octet having 8 bits only. Each octet doesn't have 9, 10 bits, right? If you having 9 bits, 10 bits, then the combinations also it is going to increase. Clear, guys? So 0 to 255. 0 to 255 also, it's a very huge value. Got it, guys? So no one they are going to connect more than 200 IP addresses in each network. So because of that reason, those peoples, they introduced to us IP address classification. IP address classification. And we divide horizontally. Now we are trying to dividing vertically. Vertically means 0 to 255. So here we divided total 32-bit into 4 octets. Again, each octet we are trying to dividing into multiple classes. I hope you got it, guys. 0 to 255, it's a very huge combinations. So ICNN people, what they did, they introduced to us IP address classification. Class A, 0 to 127. Class B, 128 to 191. Class C, 192 to 223. Class D, 224 to 239. And Class C, 240 to 255. Total 0 to 255 combinations. So they introduced to us IP address classification. How many classes will have? 5 classes will have. Class A, Class B, Class C. And Class D and Class E. Guys, Class A, Class B, Class C for LAN and WAN purpose. Got it? Class A, Class B, Class C for whom? For LAN and WAN purpose. Class D for multicasting. Class E for research and development. Got it? So as an administrator, we are going to use class A, class B, and class C. No need to bother about class D and class E. Clear? Class A, class B, class C. For whom? For LAN and WAN purpose. Who will manage the LAN and WAN? As an administrator, we are going to manage the LAN and WAN. Class D for multicasting. Class E for research and development purpose, R&D purpose. Got it, guys? So clear? Class C, class C multitasking, class D multitasking, class C research and development. Right? First three classes only we are going to use. And class D, class C, we are not going to bother. Right? Okay. Now you need to get one doubt. Suresh Kumar. Sir, why class A 0 to 127? Why not 0 to 191? Then which basis they define the classification? This is a genuine doubt, right? Yes, no. So class A, why 0 to 127? Why not 0 to 191? Then which basis they define the classification, class range? With the help of priority bit. IP address classification done by using priority bit. Got it? IP address classification done by using priority bit. Okay. Class A priority bit is 0. Because of this priority bit, we got a 0 to 127 range. And class B 10, class C 110, class D 1110, class E 1111. Those all the priority bits, right? What is priority bit? Okay. IP address classification, it's done by using priority bit. Okay, we agree with that. Okay. Then what is priority bit? Huh? Gattiga. Speak little bit louder, then I can able to hear you. Yes, guys. What is priority bit? A most significant bit of the first octet we are going to consider as a priority bit. Huh? Most significant bit of the first octet we are going to consider as a priority bit. ఒక్క ముక్క అర్థం కాలేదు, నాకు అర్థమైంది. Right? So I hope you are unable to understand. I know, right? Okay, don't worry. I'll tell you. Okay. So IP address classification done by using priority bit. Right, guys? So class A priority bit is a 0. Class B priority bit is a 10. Class C priority bit 110. Class D priority bit 1110. Class E priority bit 1111. Got it, guys? So IP address classifications done by using priority bit. What is a priority bit? It's a most significant bit of the first octet. Most significant bit of the first octet we are going to consider as a priority bit. Now, what is the most significant bit of the first octet now? How you are going to get the most significant bit of the first octet? With the help of binary calculation. Got it, guys? Guys, my humble request to you peoples, don't by heart the IP addresses. Class A 0 to 127, class B 128 to 191. Like this, don't do. Try to understand the concept. I will give some hints. Remember those hints. If you're explaining like this in interview, 100% you're going to get the job. Guys, so before discussing about AWS and DevOps question, people, they will ask about networking and Linux. Remember. Okay. Directly, they are not going to ask the DevOps questions, and directly they are not going to ask AWS questions. First, they will check at least you will have the basic knowledge or not. Got it? Right? So how we are going to get the most significant bit of the first octet? With binary calculation. Right, guys? So how many people you know binary calculation? How many of you know binary calculation? I think triple E peoples, they know binary calculations, right? So, right, okay, no need to bother. Just I'll give you a small example. According to that, you can do, right? So this is numerical calculation, right? So 2 to the power of 2 is equal to 4, right? 2 to the power of 2 is equal to 4, guys. Clear? Okay. So this is numerical. 2 to the power of 2 means 2 bits. That's it now. 2 to the power of 2 means 2 bits. Can we write this numerical calculation into binary combinations? Yes. 2 bits, right? 2 zeros, first combinations is equal to 0. Next combination 0, 1 is equal to 1. 1, 0 is equal to 2. 1, 1 is equal to 3. How many combinations? 4. 2 to the power of 2 is equal to 4. I hope you understand now. Do we have after 1, 1? There is no possibilities here. We'll have only 4 possibilities. 0, 0 first possibility. 0, 1 second possibility. 1, 0 third possibility. 1, 1. Then after 1, 1 there is no possibilities, right? After 1, 1 we are unable to continue, right? So 4 combinations. This is binary calculation. Okay. Like the same way, each octet having how many bits? 8 bits, right? So 8 bits means 2 to the power of 8, 256 combinations will have, right? 8 bits means, can we write 8 zeros? That's it now. 2 bits means 2 zeros means 8 bit means 8 zeros we can write, right? So 8 zeros is equal to 0. 7 zeros 1 is equal to 1, second combination. 6 zeros 1 0 is equal to 2. Like the same way, if you're continuing this calculation in one place, okay, that is a 127. First bit it will become 0, and then last 7 digits it will becomes ones. 7 ones will have, that is 127. So now this is a priority bit 0. A most significant bit of the first octet we are going to consider as a priority bit. 0 is a priority bit for class A. How they got defined? 0 to 127. So here 0 we got, and this is 127. 0 is a priority bit for class A. 0 to 127 is a range for class A. Based on this priority bit, they define the classification. Yes, no, ఏంటి మన బ్లాక్ షర్ట్ అర్థం కాలేదా? అర్థమైందా? అర్థం కాలేదా? రైట్. సో 0 to 127. Got it, guys? So first bit is a 0, right? And remaining all ones were in 127. So now we are going to consider this is a priority bit. Combination 0 to 127. Guys, no need to bother. If you are unable to understand, even there is no issues, I will teach you one more way. This is actually how they got defined, means with the help of this binary calculation. We'll have our own way. That is a different story. I will tell you, don't worry. Okay. Next, we are going to continue the calculation. Then 1. After that, 7 zeros. That is 128. Then 1, 7 zeros, 6 zeros, 1, 128. Like this, if you're calculating one place, 1 0, and after 1 0, everything it will become ones. That is 191. So priority bit is a 10, combinations 128 to 191. Got it? So actually we end with 127. Class B we need to consider from 128. 128 to 191 because 10. After 10, everything it will become ones. Now those both the bits we are going to consider as a priority bit. And again 192 to 223. After 110, everything it became ones, that is 223. Then class C 192 to 223. Like the same way 224 to 239, 242, 255 like this. I hope you're clear, guys. Clear? Yes, no. Non-technical peoples also no need to bother. So technical people, I hope you understand, right? Non-technical peoples also, they can able to understand very easily. It's not a big deal. It's not a rocket science, right? For non-technical people, I have different way. Don't worry. So who doesn't have knowledge in binary calculation, better to go with now what we are trying to discussing, that with the help of that calculation easily you can able to get. Don't by heart the IP addresses, right? Don't by heart class A 0 to 127, class B 128 to 191 like this. Okay. So if you know the binary calculation, you can do. Maybe if you're feeling tough for doing the binary calculation, right? We have different way. Don't worry. Just what you need to do, you need to remember priority bits. It's very easy, right? Class A 0, class B 10, class C 110, class D 1110, and class E 1111. That's it. I think it's not a big deal to remember, right? 0, 10, 110, 1110, 1111. It's very easy to remember, right? Okay. You know this, right? Priority bits, you know. Okay. Each bit having how many? Sorry. Each octet having how many bits? 8 bits. Total 4 octets will have, each octet having 8 bits. Each bit having one fixed value. That is also you need to remember. You should remember the priority bits 0, 10, 110, 1110, and 1111, right? And then each bit having one fixed value. Total 4 octets, each octet having 8 bits, each bit having one fixed value. Got it, guys? Total 4 octets. So each octet having 8 bits, each bit having one fixed value, right? So let's see, guys, here. Assume this is one octet. I used zeros. If you want, you can use zeros and one combinations. If you want, you can use one, whatever, if you want, you can. But I used zeros here. Total, how many bits will have in each octet? 8 bits. Means 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8 zeros will have. Total 8 zeros. Clear? Each bit having one fixed value. That's it. That is also very easy to remember. It's not a big deal. So this bit value 2 to the power of 0. This bit value 2 to the power of 1. This bit value 2 to the power of 2. This bit value 2 to the power of 3, 2 to the power of 4, this bit value 2 to the power of 5, 2 to the power of 6, and 2 to the power of 7. It's very easy, right? 2 to the power of 0, 1, 2, 3, 4, 5, 6, 7 total. Each bit having one fixed value. Now we know priority bits and as well as each bit value. I think it's not a big deal to remember. So you need to remember the IP address range. It's a bit difficult to us. We need to buy hard. Don't buy hard. Just try to think technically and then try to understand how we are getting those ranges. If you're explaining like this, definitely you are going to crack the interview. Got it, guys? So now, okay. So first class A range we need, right? So class A priority bit how much? 0. 0 means 1 bit. Calculate first bit. How much? 2 to the power of 7. How much? 128. Means 128 combinations. We are writing from 0, then we got a class A range 0 to 127. If you're writing from 0, we should do minus 1, right? 128 minus 1, 0 to 127. Class A range, simple. We got no need to do binary calculations and those all stuff. Right? Got it, guys? Right. Next, class B priority bit. How many priority bits will have for class B? Yes. How many priority bits will have for class B? 2, 1, 0. First bit plus second bit. First bit value how much? 2 to the power of 7, 128. Second bit value how much? 2 to the power of 6, 64. 128 plus 64 how much? 192. Here we end with 127. Always we need to start from 128. Then minus 1 we should do right from 192 because we are writing from 0, 191. Simple. Class B range, we got it. It's very easy, right? No need to buy hard, right? Right. Next. So 110 class C priority bit 128 plus 64 plus 32. 3 bits. How much? 224. 224. Right? Got it, guys. Then we end with 191. Always we need to start from 192. Then we should do minus 1, 223. 224. Why minus 1? We are writing from 0. So 223. Now, 1110, 4 bits, right? 128 plus 64 plus 32 plus 16. How much? 240. So now we end with 223. We need to start always from 224 to 239. Last class E, blindly you can write 240 to 255 because more than 255 combinations it doesn't have. That's it now, guys. Did you feel it's a difficulty here? Did you feel any difficulty here? It's very easy to understand. In this way, if you're explaining to interviewer, 100% he's going to impress. Clear? Yes, no. Don't buy hard. Right? So who have the difficulty in binary calculation, better to use this calculation. Easily you can able to get the range classification. Right? Okay, good. I hope you got it, guys. I hope you understand. Good. Non-IT peoples, especially for non-IT, IT people, they know those all stuff. It's not a big deal for them. They are very intelligent people, very intelligent peoples. Okay. I'm talking about non-IT, right? Okay. Right. Good. Paresh. Right. Next, coming to IP addresses and classes. Okay. Class A, class B, class C. As an administrator, we are going to use only class A, class B, and class C, guys. Okay. So they got divided into network and host positions. They got divided into network and host positions. Got it, guys? Class A, 1 network, 3 hosts. Class B, 2 networks and 2 hosts. Class C, 3 networks and 1 host. Got it, guys? So 1 network, you can say it's a first floor. and 2 network, second floor, 3 networks, third floor. Now we need to avoid the communication between those networks. Class A, first floor peoples, they should not communicate with class B, second floor peoples. Class B, second floor peoples, they should not communicate with third floor peoples. Class C, it should not communicate with first floor and second floor, means class A and class B. Then how to avoid the communication? Simple, guys. Coming to our organization, coming to our institution, right? So we have how many floors? 3 floors we'll have in this building, right? First floor, second floor, and third floor, right? 3 floors we'll have. Can we able to communicate directly from first floor to second floor? Why? Direct pay podama? ఇక్కడ నుంచి మీ ఇంటి దగ్గరికి వినిపిస్తుందా? ఏం చెప్తున్నారు మేడం మీరు? మేడం, డోంట్ టేక్ దట్ మచ్ ఆఫ్ సీరియస్. ఓకే, సో గట్టిగా మాట్లాడితే వినిపిస్తుంది అంటే వినిపిస్తుంది. నా గొంతు మైక్ లేకపోయినా వినిపిస్తుంది వాళ్ళకి. ఓకేనా? సో లెట్స్ సీ హియర్. సో వీ హ్యావ్ 3 floors. Class A is a first floor, class B second floor, class C third floor, right? How we are avoiding the communication between those floors? With the help of compound wall. That's it now. Compound wall, and then we'll have ceiling, right? Top, right? Okay. So yes, no. So class A should not communicate with class B. Class B should not communicate with class C. Class C should not communicate with class A, class B. So how to avoid the communication? Usually if we having 3 classrooms, then we are going to use compound wall to avoid the communication. If you doesn't have the compound wall, then what will happen? Linux class, it's mixed with AWS. AWS is mixed with DevOps, and DevOps it's mixed with Python. Okay, Java, right? I hope you got it, guys. So we'll have some problem. We are unable to understand those all the 4 to 5 faculties if they're trying to teaching into one classroom. So because of that reason, what they're doing, they're trying to dividing into multiple classrooms. How they're avoiding the communication with the help of compound walls. Like the same way here, we need one compound wall. Compound wall means don't get the like bricks and those all cements and those all stuff here. So here, subnet mask is a compound wall. To avoid the communication, we are going to use subnet mask, right? How we'll get the default subnet mask for each and every class? Guys, one small formula or definition, whatever if you want, you can say. All the network bits, it should becomes ones, and all the host bits should become zeros. That is a default subnet mask for class. Got it? All the network bit, it should become ones. All the host bits, it should become zeros. How many network bits, how many network octets will have? 1. How many network bits will have? 8. Each octet having 8 bits, right? 8 ones dot 8 zeros dot 8 zeros dot 8 zeros. 8 ones dot 8 zeros dot 8 zeros dot 8 zeros. Guys, if you find 8 ones, okay, from anywhere, blindly write 255. If you want, you can convert with the help of binary calculator. 8 ones, if you're converting into 8 ones binary values, if you're converting into numerical, the numerical value is 255 for 8 ones. If you find 8 ones in IP addresses, blindly you can write 255. Okay, 255 dot, always 8 zeros means 0 only, na? 0 dot 0 dot 0. So this is a default subnet mask for class A. It will act like as a compound wall. I hope you got it, guys. Clear? Yes, no? Right. So coming to class B, 2 networks, 2 hosts, 8 1s dot 8 1s dot 8 zeros dot 8 zeros, 255.255.0.0. I hope you got it. Clear, guys? Yes, no? And this is a default subnet mask for class B. And class C, 3 networks, 8 zeros, 255.255.255.0. Without subnet mask, we are unable to define the network, remember. Got it, guys? In Windows, by default, it will take, but in Linux, it's not like this. We need to assign the subnet mask manually. Clear? So what is subnet mask? To avoid the communication. So how we'll get the default subnet mask? With the help of converting all the host bit into, sorry, all the network bits, it will becomes ones, all the host bits, it should become zeros. Like this, we'll get the default subnet mask per class. All network bits, it should becomes ones, all host bits, it should become zeros. That is the default subnet mask per class. Right? Got it, guys? Good. Right. I hope you're clear as of now. If you're having any doubts as of now, please. Okay. Next, class A, 10.0.0.0 to 10.255.255.255. Now, most of the people, they have this doubt. Sir, why we need to use 10.0.0.02? Why we need to 172? Why we need to use 192 like this, right? Let's see. Now we are going to get clear this doubt, okay? So class A, 10.0.0.02, 10.255.255.255. This is class A range. Class B, 127.16, 172.16.0.02, 172.31.255.255. This is class B range. Class C, 192.168.0.02, 192.168.255.255. Guys, this range is a private range for internal communication. I hope like you have completed VPCs, right? So while you are trying to creating the VPCs, VPC means internetwork, private cloud, right? Virtual private cloud, internetwork, our private network. In private network, why we are trying to creating the VPCs with 10.0.0, 172.16.0.0 means it's a private range. Apart from this range, everything is public for internet. Clear? Because of this reason, most of the people, they are going to use that particular range itself only. Got it? నేను కొంతమంది నేను 11.0.0.0 ఇస్తానంటే ఇచ్చుకోండి, మనం ఏం చేసేది లేదు దానికి. బట్ so as per the rule, so we need to follow 10.0.0.0 to 10.255, 255, 255, right? Got it, guys? I hope you're clear. If you're having any doubts, any questions, please. So I hope you're not feeling bored. If you're not feeling bored, I'll continue for 15 minutes. Because one small calculations will have, as an administrator, we should know this. Who have the 5 p.m. batch? I think 5 p.m. there is no batches, right? From 6 p.m. onwards. No issues, will continue. Right? Yes, guys. So clear online. I'm not getting any reply from you. So only Paresh is giving the reply. And what about remaining peoples? Right. Good. Right. Okay. Guys, as a system administrator, we should have good knowledge. You'll do practice. What practice, man? So we'll do tomorrow practice. Okay. So today class practice. I'll show you, don't worry, practically everything. Okay. We are going to establish our own isolated network. There at the time I will show you practically, don't worry. Okay. Try to understand the entire theoretical concept, then we'll do the practice. Okay. Right. So as an administrator, you should know thoroughly about IPv4 network. Got it? For example, suddenly your organization peoples, they try to starting one new branch. Okay. You are admin. You need to establish the one network, legacy network. I'm not talking about cloud. In cloud also same process. But in cloud virtual will have, coming to legacy physical will have, that's it, right? Okay. So you need to establish one lab, for example. Okay. So what kind of IP address you are going to use, how you are going to establish the lab. You should know which IP address is a preferable, which class IP addresses are preferable for that particular network. That's it, no? For example, so we visit to somewhere in shopping mall. So we are trying to purchasing the clothes, right? According to my size, I need to purchase, right? According to your size, you need to purchase, right? Then I don't know, I'm trying to purchasing for someone, I don't know the size, then how you are going to purchase? It's a bit difficult to us. Like the same way, according to our organization requirement, how many missions will have, what kind of class we need to take for those missions, how much size of the network we need to establish, those all we should have the knowledge. Yes, no, we are trying to designing our own network there. Without knowing class A, how many networks will have, in class A, how many hosts we can able to connect in each network. Without knowing this, can we able to establish whether is a class A is a preferable or class B is a preferable or class C is a preferable? Without knowing this, how you are going to define the IP address classes there? So we should know in class A how many IP addresses will have, how many IP addresses means how many networks will have, how many hosts we can able to connect into each network. Let's see here, guys. This is one network, man. Assume this is a class A network. Like this network, with the help of class A, how many we can establish? This is one network. 2, 3, 4, 10, 20, 100, 2000, 40,000. How many networks we can able to establish? In each network, we'll have 4 missions, right? Like the same way, with the help of class A, how many hosts we can able to connect each network? Got it? Without knowing those stuff, how you can able to define which class is a preferable for us? Yes, no, right? So let's see here. We have few formulas. It's not a very lengthy formula, small formulas only, no need to bother. Okay. See guys, we need to know how many networks we'll have in class A, how many hosts we'll have in, we can able to connect into each network in class A, right? So prerequisites, we need networks. N is equal to 8 because only one network octet will have. H is equal to 24. 3 host octets will have. 3 8s are 24. One priority bit, P is equal to 0. Then 1 bit. The 0 we are considering as a 1 bit. Got it, guys? I hope you're clear, right? Okay. So network formula. 2 to the power of n minus p. Guys, this minus 2 only for class A, not for class B, not for class C. Remember, actually formula is 2 to the power of n minus p only. But in class A, we need to provide minus 2. Minus 2 for whom? 0, 127. 0 dot 0 dot 0 dot 0. This is unknown network. Who is going to use the 0 dot 0 dot 0 dot 0 network? I hope you got it, right? 0 dot 0 dot 0 dot 0. It's an unknown network. 127 dot 0 dot 0 dot 0. It's a loop back network. Loop back. Okay. Unknown network, we know no one they are going to use. Coming to loopback, what is the use of loopback network? What is the use of loopback IP address? To check the outgoing traffic. Got it, guys? To check the outgoing traffic. Simply, you can write, if you want, you can make a note. What is the use of loopback? To check the NIC card, whether it is working properly or not, whether it can able to send the data, whether it can able to receive the data. How to check? Ping is a command, and then 127.0.0.1. If you execute this command, if you're getting reply from this IP address, means your NIC card, it's working properly. 100% interview question. What is the use of loop back? I hope you got it. What is the use of loop back? To check the NIC card, to check the outgoing traffic, whatever if you want to can say. How to check? Ping space 127.0.0.1. Then if you're getting reply from this IP address, means your NIC card, it's working properly. So because of that reason, we are not going to use those both the networks. We are doing -2. Two networks, right? -2. 2 to the power of 8 minus 1. N value 8. Priority value 1. We need to substitute those all the values into formula, right? So 2 to the power of 7 minus 2, 128 minus 2, 126 networks we can able to establish using class A. How many networks? Like this networks, how many? 126 networks. In each network, how many hosts we can able to connect? Simple, man. Each network assume this one classroom. Okay. In this classroom capacity, maybe 40, 50 peoples, right? Another classroom capacity, 100 peoples. Means how many peoples they can able to sit into one classroom. Like the same way in class A, 126 networks we can able to establish. Assume this total place is a class A. In class A, how many classrooms we can able to create? And each classroom, how many peoples they can able to sit? I hope you got it, guys. Clear? So coming to host, how many hosts we can able to connect into each network? 2 to the power of h minus 2 is a formula. -2 is a network ID and broadcast ID. Guys, class A private IP address 10, right? 10.0.0.0, right? Okay. So guys, network ID and broadcast ID. What is network ID and what is broadcast ID? We are not going to use network ID and broadcast ID for hosts. In between, we'll have valid IP addresses. Only valid IP addresses we are going to assign for host in network. Remember, host, mission, computer, lab, whatever if you want, you can say. Right, guys? So how you are going to get the network ID? All the host bits, if it is become 0, that is network ID to identify the network. Clear, guys? All the host bits, if it is become 0, that is a network ID to identify the network. All the host bits, if it is become ones, that is broadcast ID. So without broadcast ID, you are unable to broadcast the data in network, remember. So this is a broadcast ID for class A 10.255.250. All ones means 255 only, na? 8 ones, 8 ones, 8 ones, 250, 255. This is broadcast ID. Network ID and broadcast ID, we are not going to assign for hosts, remember. Only valid IP addresses 1 to 254 will have. Only those valid IP addresses we are going to assign for computer in a network, remember, host in a network. Got it, guys? Because of that reason, we are doing -2 here. 2 to the power of h minus 2 is a formula to know the host count in each network. Clear? So 2 to the power of h 24 minus 2. How much? More than 1 billion will have. Host by network. How many missions we can able to connect, see, in each network? Who's going to use this network, man? If you're using this network, the broadcasting, it is going to happen. More broadcasting. While you are trying to sending the data, it will take long time to reach the destination. Sometimes the network, it is going to down. Class C, it's not that much of preferable. Maybe if you try to adding the 500 missions into one network, then you can go with class C. Sorry, class A, not class C, guys. Class A, it's not a preferable. Class C is a preferable. People, they will ask like this question. Class C is a preferable network. What kind of class is a preferable for to establish the network? Always class C is a preferable class. I hope you got it, guys. Like the same way, class B. How many networks? 2 networks, 16. How many hosts? 2 hosts, 16. Priority bit 210. Right? The network. Don't give -2 here because we doesn't have 0 and 127. So class bit will start from 128. No need to bother about 0 and no need to bother about 128, 127. It will start from 128, right? So now substitute those value into this formula. 2 to the power of n minus p, 16 minus p, n means 16 minus p, 2, 1, 0, 2 value, 2 bits, right? So 16 minus 2, 2 to the power of 14. How many? 16,338, sorry, 16,384 networks we can able to establish using class B. Okay, clear? Next, host 2 to the power of h minus 2. Network ID, guys, remember each and every network it having one network ID, one broadcast ID, we are not going to use. In between valid IP addresses only we are going to assign for hosts. Remember. Right. 2 to the power of 16 minus 2, 65,536. 65,534 host we can able to connect in each network in class B. Got it, guys? I hope you're clear. Then class C, 3 networks, 1 host, 24, 8. Priority bits, 3 bits, 110, 3 bits. Then formula 2 to the power of n minus p, 2 to the power of 24 minus 3, 21. So how many networks? 2 lakhs networks, more than 2 lakhs networks we can able to create. And how many hosts we can able to attach into one network? See, guys, 2 to the power of h minus 2. Minus 2 means network ID and broadcast ID. 2 to the power of 8 minus 2, 256 minus 2, 254 valid IP addresses will have in each network. So who's going to connect in each network more than 200 IP addresses, 200 missions? Because of that reason, we are saying class C is a preferable network. Got it now? Class C is a preferable network. Clear? I hope you're clear about IPv4 very clearly now. If you're having any doubts, any questions, please. Tomorrow, don't miss. Excuse me, guys. So tomorrow, don't miss the session. Tomorrow, we are going to discuss about subnetting. How to divide one network into multiple networks. Clear? So how many of you know how to create the VPCs? Steps? Tell me. So got it. Guys, Manikantan, he's saying like mosquito coil it's showing. What about remaining peoples? Huh? Yes, guys. What about remaining peoples? I hope you're clear. Guys, without knowing IP addresses, remember, you are unable to become as a cloud engineer. Right? Got it? Then how to create the VPCs? How to create the VPC, man? Steps. VPC name. ఉప్పులో కాలేశ్వర్లేండి అంతే guys 100% definitely if you are try to attending the cloud interview they will ask like this question if you're giving the answer first we need to create VPC then subnet then routing table then IGW so they can able to understand you don't know anything. VPC subnet internet gateway then routing table. This is a very, very important flow steps we need to follow. Don't say antena. ఎప్పుడు చెప్పాలి అది అప్పుడు చెప్పాలి ఎప్పుడెప్పుడు చిన్నప్పుడు చెప్తే కుదరదు. See, we have few rules and regulations, right? So మనం తర్వాత రేపైనా క్రియేట్ చేసుకోవచ్చు నేను కాదంటం లేదు. How to create the VPCs means you should follow those 4 steps. If you want to, you can search in official content, then you can able to know. Right? In interview doesn't have this much of discussion. He's going to ask next question. That's it. నేను చెప్పింది కరెక్టే కదా అక్కడ రాదు. Try to understand. Okay. Okay, guys. See you tomorrow. Don't mess. See you guys. Yes, online. I hope you're clear. If you're having any doubts, any questions, please. I hope you don't have anything, right?